Hello everybody to this new video. I'm glad that I can show you some extension of my previous video. I will show you a link in the description. There I already got the parametric model of a truss. We got some the coordinates and the member indices. But now, since I already have this definition, I want to use Caramba for the structural analysis. I will show you also some cases there. Then I will send this data to Speckle and I will build new properties from Caramba for each member. And what I will also show is collaboration with Python, where I will extract the Speckle data and send to one pager Streamlit app. So stay tuned and let's get started. Now I want to make a step into structural analysis, but first I want to be able to mirror these diagonals. These were my curves B. Let's just grab, we want to mirror the geometry and we want to have the original curves. Around which plane we need curve middle. I need my verticals. So these are C, the 5 number. List item, it doesn't matter, I just need one point for the plane to mirror around, and I need stream filter to switch between the original and the mirrored geometry, and some boolean toggle. Okay, so this is, I don't need this. Let's just hide this, get new curves. Okay, now I see them both, but let's check here. I need to collect them in a list. ABC and okay, 8 are the chords, the diagonals, and the verticals. If I go there and flatten again this stream, 17 lines, 17 lines. I want to get rid of this merge. Okay, just a second. And this will be the flatten list, my geometry, my flattened members for Speckle. These are my indices for the members later. This, I don't need this anymore. Not sure. Yes, okay, now I see the two opportunities that I have for the diagonals, which I wasn't able to find in the lunchbox component. So far as I know, okay, let's just leave it like this and go straight to Caramba. First I want this to make maybe a cluster. Okay, let's just leave it like this. These were my coordinates, these were my members. Okay, this is the data that this was string. This is the data that I had. I'm gonna optimize also the speckle properties once I have the cross section and properties from analysis later. So first, these were my elements, and I'm just wanna I just gonna take the under chords for the supports. Let's just join curves. So let's explode 3. Match outputs. Yes, I could do this. I need the first one, so the both upper and lower curves. Let's take. Okay, the first is the lower and extract endpoints. This will be my supports. Once here and once there. From entwine, I'm going to take the lines. Here, I'm leaving this bending at true because later I'm going to assign joins to all of the members. Let's see what I already can plug. Yes, flatten. These are the supports. I'm explicitly going to write here true on the bending. For load, let's just make a vector negative unit z, getting list items, nodes, oops. Okay, this changes the each points, so I'm going through. Let's say I want to apply load in the middle there on this node. This is the position of the load, and I can plug it also here. Okay, so in the plane I want to have a fix this support and rotation around x axis. Okay, and the other support is going to have fixed translation in y and z and in y, so out of the plane, and z direction. Let me see. Yes, I can analyze it already. All right. In a moment I will make the cross-section optimization. Let this display the cross-section. Okay, right now there are circular cross sections. Let's try this. Okay, yeah, now I can reduce a little bit, and this is our deformation. So the problem is not the problem, but the setting I have to make is it's showing now some bending moments, which for a truss is not right. So I need to add the joints, which I forgot to place first. So here under beam joints, I need to change some stiffness. Yes, in the plane, so around y-axis, I need a vector 1, 0. Let's make it panel. So this is a rotation stiffness around y-axis, and at the same time I have to add a joint, because otherwise it's giving error. And I'm assigning this to joints. Now I see them, and if I switch to moment diagram, I don't have any more. I don't have any kilonewton. I can reduce this also, and now I'm getting the diagrams. Let's see here. Okay, supports, reactions. Okay, let's leave it like this. And now if I switch, I have the different static schemes. Let's see what I can do with the materials. Okay. And let's make our list with the cross sections. Now I'm leaving here all to get a list of all possible cross sections. And I'm gonna analyze with with the first cross section, let's say. And all of the cross sections I wanna include in the optimize cross section component. Here is my model, and here it will try to optimize. Let's see, now I have all of them HEA 100, and after optimizing I want to say I want the maximal utilization to be 0.8. Okay, if I were to make the load ambition a little higher, we can see that these diagonals are getting the 120 cross section, which is the point of this optimization, or for example 140 if I increase the load. Let me check and deconstruct element cross sections. Okay, now I'm getting the table with the used cross sections. So we can check also the utilization in results. Zero point 0.7 something, so smaller, 0.8. Okay, let's make this in a group. Let's check, for example, straight ratio. Okay, this was one step from our workflow. Let's get towards Speckle optimization. Okay, I wanted to optimize a little the Speckle settings before I publish the model again. So here I want the collection to rename the collections first as members and coordinates. And this will be my two collections with metadata. So for the coordinates and indices, like two tables, and one with geometry for the members. So here was my list with 17 members. So here I want to rename this as to leave only members there. And to add new properties for the cross section and the length of each member. So properties. So let's see where I can grab the names from. I think from here, and I will need only the name part. So I tried to make some simple. I'm just going to paste this small script. First I need to rename this. This will be my texts. Okay, I need to change the type, sorry. List access and string. Now I have what I need, only the profile names. These are my cross sections, and again from here I will need the element IDs. I just noticed this empty because I forgot to give IDs for the elements. So this is gonna correspond with this tree structure. So I will have multi-line text. And now I think, yes, now I'm getting this data. Going here. So for the keys I will need text indices to change automatically. So list indices from my members from 1 to 17. Panel, I want to write something, for example, in meters, length 0, and I will connect this with the indices. So length 0, 1, 0, 2, and so on. And element ID, is this diagonal, vertical, and what? But in the middle I will need a separator, so a space. Sorry. just empty panel with a space. So I'm getting the keys. This is like I prefer this to do. You can do it otherwise. So this is gonna be the first key. Connected with curve length, the length of each member. Around this to two decimal places, entwine once, entwine for the values, cross sections. Okay, this actually has to be my cross section values. Let's make them text. Let me see what I'm getting. I need to flip matrix, I think. Yes, I'm getting against each section name the corresponding length, and this is going to be my values. I need to entwine here. It says so in meter. Now I need to add the text, the string cross section, and to duplicate the data. Duplicate this cross section like a table. How many times? The length of the members. So list length 17 times. So count. And to entwine this here, I need to flip the matrix again because I need two items in a branch. Yes, and this is going to be my keys. Okay, now I think I'm getting what I want. This goes to properties. These are my members. This is, for example, properties for one member: cross section and length. Cross section, length. Okay. Okay. This is the one collection members, and then in the other coordinates I have, as already seen in the last video, the node coordinates in meters for each point, and member indices. So member is built from node with number this to node with number this, and so on. So this was the Speckle optimization. So here I want to notice something. Here I have to graph this input to have two collections. So nodal coordinates, member indices, I have two branches, because otherwise there were four. It wasn't correct. So now I'm in pie charm, and I have a parallel the code that I've already tried, and the other side I will make the step by step what the current steps are making to the page. So I think it will be interesting. to reach in the end this kind of interface. Of course, it's very raw, and we can make this better in the future. Okay, these are the packages that I'm gonna need. These are from Speckle, and for the tables I'm going to need the pandas. This is the Streamlit Python package and OS. First we need the host. This will be the Speckle systems, and I gonna authenticate with the token. Let's see, and define main, and in the end I'm going to need this. And I've already get my token from the Speckle app. Let's see how can I be sure that I'm authenticated. So I'm adding a title to the page, and this is the corresponding usage of the function inside the main function at this level. Okay, so let's try to execute this. I'm executing the page locally. Okay, let's we see in one row first that I'm authenticated successfully from this part of the code. After that, I will here are defined some helper functions. So first I need to extract project ID, then the models inside this project, then the versions inside this model, and this happens with this client model get models, client version get versions, and latest object is realized with the transport when we have the client and the project ID. This is the referenced object that is returned. Okay, let's see what happens. Now I have to use these functions on my main function. So I'm getting the client, I'm getting the project URL. When the user gives user input, text input, and pastes the Speckle project URL, which we can see here. After that, we extract the project ID. We can see it on the screen, and then we extract the models from this function. We getting through each of the models. Actually, let's run this to see it. Here I already see the user input. This is my project URL. Here I can select from my existing models on Speckle. I can see the ID, I can see the latest version. Okay, till now, so far so good. We are in the main function. Latest version, okay. Here we received the latest version, and now we are searching for our target elements. So I want to go through each of the Speckle objects that I have. Doesn't matter if just all of the Speckle data objects, and searching if they have properties here. And first I can see that this is the bigger Speckle core model, and it has elements, and it has also name attribute. I'm searching for these objects and keywords, coordinates, and indices. If somewhere in the name, I'm interested if there are in somewhere coordinates and indices, and it will keep searching. So this is one nested function. I'm getting name of the current object, and um, I ignore if there are upper or lower cases in keywords. In this, what I'm searching is name of the object, and I'm searching also if there are properties, and if this properties is dictionary. So then I am returning results of these objects. This I'm returning these objects as results. And also with this function, if there are lower some other level of elements, it will assign the same logic. uh, okay, so this is okay. And here on the other side, what I'm making in the main function is a streamlit button. So I want to extract list of coordinates. This is the name of the button, and if I push the button, I will receive the objects, these coordinates and indices. Found matching elements, so how many elements there are found, so how many, in my case there are two tables with the searched properties, indices and coordinates. Okay, I'm getting the name, the title, and this data frame is getting the title. This table is getting the title that I gave. I'm writing the title first and then the data frame with two columns. Let's see if this is functioning. Project ID, model version. This is the button, extract list of coordinates. And here I wanted to print here. Streamlit right name is name. So I want to get the current object. I'm going through all of the objects. In Speckle, I'm getting their names. So grasshopper model is one object, then all of the members, all of the coordinates, nodal and indices, and these are the names. And in these names I'm searching for properties. First I'm searching for it, are there these names and these names, keywords. If there are these keywords, then I'm getting their properties, and I'm extracting two data frames from these properties. So matching elements are two, so two tables. Okay, so there was also a mistake here. The sequence of these inputs was switched. So first were the nodal coordinates 10, and the member indices that are building the members are 17. And let's run back Streamlit. Yes, coordinates are now this in meters and so on, and the memory indices are whole numbers like integers. For the number of each node. Okay, so that's it. I hope it was interesting for you, and see you in the next video. Thanks and bye.